instead of wasting your guys' time. So the quiz is today. I had a couple people send me problems. So if you guys get stuck on something, let me know. If you want me to work it out, I will work it out as soon as I can. Sometimes I'm just not home. I don't have like pad of paper with me to even work it out. So I have to wait till I get home or at a time that I could get to it when my kids aren't with me. All right. A lot of this, again, is all formula based. So I need to see what am I given, what am I looking for? And so for this first problem, we want to know what is the value of sine of 2x. So I know that sine of 2x by my double angle formulas is going to be 2 sine of x cosine of x. So I need to know what is sine of x and what is cosine of x. Those are the two things that I'm going to need to know. So I go and see, well, what am I given? I'm given tangent, and it's 7/2. So when I see that, and I see that I'm given a quadrant or this value here, I know that I have to do the triangles. So if tangent of x is equal to 7/2, this is my opposite side, this is my adjacent side for my right triangle. So my opposite side was 7, my adjacent side was 2. So I needed to solve for this hypotenuse. What is my hypotenuse going to be? The other thing they gave me is that I'm between 180 and 270 degrees. So 180 and 270. That means I'm in quadrant 3. So I know that I'm going to be in quadrant 3. If I'm in quadrant 3, all students take calculus. Then tangent is the only one that's positive. And we can see that tangent was a positive number here. That means when I solve for my sine of x for here, I know it has to be a negative. And when I solve for this cosine of x, I know it has to be a negative as well because I'm in quadrant 3, and that's what this is telling me. All right, so we need to figure out then what is this hypotenuse going to be. So it's 7 squared plus 2 squared is equal to my hypotenuse squared. 49 plus 4 is equal to my hypotenuse squared. So 53 is equal to my hypotenuse squared. Take the square root of both. Then this hypotenuse has to be the square root of 53. Square root of 53. So then if I want to know what is sine of that value, sine is opposite, is going to be my opposite over my hypotenuse. So it's going to be a -7 over the square root of 53. Some of you guys go, but do I need to rationalize this? Wait to do anything until you start working through, because sometimes they rationalize, sometimes they don't. You can always do it at the end. Okay, so then I look here, my cosine is going to be my adjacent. So it's 2 over the square root of 53 over my hypotenuse. So I plug in my values. I have 2 times -7 over the square root of 53 times -2 over the square root of 53 is equal to, a negative and a negative is going to make those a positive. I have 2 times 7 is 14 times 2 is 28. The square root of 53 times the square root of 53 is just going to be a 53. And I can't simplify that. So this is the answer we were looking for. This is done, simplified. And it matches this one right here. All done. So this one I had to draw triangles. When I see that fraction in my quadrants, triangles. When I see something like this, 0 to 2 pi, that's going to be my unit circle. So you can see the differences. All right. So I want to know what is x. What are the possible solutions for x? And I know sine of 2x minus sine of x is equal to 0. Now, some of you guys go, oh, well, I'm just going to pull out an x. No, these would have to be the exact same things. This is like saying sine of y and the sine of x, and they're not the same. You can't just factor something out. It does not work like that. What I do know, though, is that sine of 2x, this value right here is 2 sine of x cosine of x. It's my double angle, right? That's the exact same thing we already saw up here. same thing. So minus my sine of x is equal to 0. So minus this. And then if I look here, I notice that both of these have a sine of x. They're two separate terms because they're separated by a minus. So I can factor out a sine of x. And when I do that, I'm left with 2 cosine of x minus, there's a 1 left there. It's not 0. There's that 1 is equal to 0. And then by my zero product property, I could set each one of these pieces equal to 0. So sine of x is equal to 0. And I have 2 cosine of x minus 1 is equal to 0. And then I can add 1 to both sides. So 2 cosine of x is equal to 1. Divide by 2 cosine of x is equal to 1/2. So I look over here. When is sine going to be 0? So I look for my sine value. It's 0 here at 0, and it's 0 at pi. Oops, can't see that one. And it's 0 at pi. So I have 2 solutions for this. So x is equal to 0 and pi. And then I look to see when is cosine 1/2. When is cosine 1/2? Cosine, my x value is 1/2 here at pi over 3. And cosine is 1/2 here at 5 pi over 3. So those also has 2 solutions. So x here is going to be pi over 3 and 5 pi over 3. There's my solutions here and here. So I look over here and which one does it match up with, which has it, and it's going to be this last one. And we're all done. All right, these simplify ones. Sometimes you guys are like, simplify. I don't like them. I don't get how to do that because you don't know exactly what it's going to look like. Sometimes you guys do better with solving. So I kind of look and see, okay, well, what are some things that I can actually work with and simplify? And I see this cosine of x and a sine of x, like there's not really anything you can do to it. If it was a tangent, maybe you write it as a sine over cosine, but just these, there's not really much you can do. What I do notice though is that it has this double angle right here. So that's going to be my best bet. The problem with this is I have 3 different options for that cosine of 2x. So this one's a little bit tricky, and maybe you do some trial and error. But I also pay attention to my denominator here. My denominator has a cosine and a sine. If things were just all in sine or just in cosine, then that might change the one I choose. But when I look here, where are we at? When I look here, I have, if things were already just in sine, I would choose this one. If things were just in cosine, I would probably choose this one. But I have cosine and sine, so I'm going to choose this one. Again, it might be some trial and error. Maybe you choose the wrong one. That's okay. You might go back and just try it again. So I'm going to choose this first one because I have a cosine and a sine already here. So that's my thought process on why I would choose this one. And so what I'm going to go ahead and do is I'm going to rewrite that cosine of 2x as my cosine squared of x. Oops, I was going to write theta. Cosine squared of x minus my sine squared of x all over cosine of x sine of x. Okay, well, what can I do? Well, sometimes we forget about this, but this is a perfect square, right? And this is a perfect square, and it's minus in between. So this right here is just a difference of squares. So if you recall, if I have a squared minus b squared, so 2 perfect squares with a minus in between, it would just be a plus b times a minus b. This is my difference of squares. So I could do the same idea with my cosine squared minus sine squared. So this just factors into cosine of x plus sine of x times cosine of x minus sine of x. And it's still going to be all over my cosine of x minus sine of x. Well, what's interesting now that when I write it like this, some of you guys might already notice that, look here, this is all together, and it's the same thing as this piece right there. It cancels out. So the trick to this was knowing your difference of squares. And sometimes we forget that. So it's good for us to practice and see it so we can remember. And we're like, oh yeah, I remember doing that. So I end up with just cosine of x plus sine of x, and it's this one right there. And this is my simplified version. All done. Again, if I go too fast, you have questions, you need further explanation, let me know. I want to be able to help you. I want you guys to understand this as best as you can. All right, I'm gonna go ahead and flip. I already know these next two problems. If I look at these, if I look at both of these, I'm given this fraction information, then I know I'm gonna have to do triangles right away. I know as soon as I'm given these fractions like this, I'm gonna be working with triangles. So those are, again, look for the clues so you know what type. Is it gonna be a triangle or is it going to be something that's on your unit circle? So those are your two options every time. All right, so I look here and I go, okay, I want cosine of 2x. Now, cosines are always the trickiest, again, because we have three options to choose from. So although I know I'm going to be using cosine of 2x, I want to see what am I given, and I know my sine of x value. So when I go to choose which cosine of 2x one I want, if I choose this first one, I need to know what cosine is. They didn't tell me that. If I choose this one, they didn't tell me cosine. But if I look here, they told me what sine is, and that's all I need to do. So if I choose this one, I don't even need to solve a triangle for anything because they gave me the information. I could choose to do one of these other ones and solve for the cosine, but then I have to create the triangle and do that work. Doesn't mean that I can't, but if I pay attention to what am I given, then I could choose the formula that's going to use what I already know. So in other words, I know that cosine of 2x is equal to 1 minus 2 sine squared of x. Sometimes, again, this throws us off, so I'm going to just rewrite this to just reiterate that this is the same thing as sine of x squared, that these two are equivalent. This is equivalent notation. And they told me that sine of x is 4/5. They told me that this value right here is just 4/5. I didn't even have to do any extra work. I just literally need to plug it into the formula. So it's 1 minus 2, and it's going to be my 4/5 squared. So when I square this, I need to square the numerator and the denominator. So this is 1 minus 2 times 16 25ths. 2 doesn't go into 25, so I can't simplify that. So I have 1 minus 2 times 16 is 32 25ths. I want to simplify that, so I need a common denominator. So this 1, I could just write as 25 over 25, right? That's just the value of 1. 25 minus 32 is going to give me my -7 all over 25, and this is the answer we're looking for. So I go here, -7 25ths. Done. So again, I chose this equation because I was given sine. It was the easiest one to work with. Doesn't mean you have to choose that. You could have gone ahead and solved for cosine, drawing your triangle and evaluating it. And my last one. We're given cosine. We're going to be from pi over 2 to pi. That means we're going to be in quadrant 2. And we want tangent of 2x. So tangent of 2x is equal to 2 times tangent of x all over 1 minus tangent squared of x. All right, so I know cosine, but I need to know tangent. That means I've got to go to my triangle. So let's go ahead and let's create a triangle that's going to correspond to what I'm given. So I have cosine of x is equal to a negative 1/3. I know I'm in quadrant 2, so all students take calculus. We're in quadrant 2, so sine is positive. So if I'm going to be looking for tangent, so if we want tangent, I know my tangent's going to be negative because I'm in quadrant 2. That's what this tells me here. So quadrant 2, sine is positive. So this is going to be a negative tangent. Well, in order to figure out my tangent, I need my opposite, over my adjacent. So I know my adjacent is 1, my hypotenuse is 3. I need to figure out what is that opposite going to be. So I have my opposite squared plus 1 is equal, squared is equal to 3 squared. My opposite squared, this is going to be just the value of 1. Well, I guess I'll work it out. Plus 1 is equal to 9. So my opposite side squared is going to be 8. And I'm going to take the square root of both sides. So my opposite is the square root of 8. This is the same thing as 2 square root of 2. But I'm not going to use that value. Again, we've seen them where they've done this a lot. And I've warned you guys about this because they'll simplify it. And then in this case, they didn't. So I saw up here that they used square root of 8, which is terrible notation. That's horrible usage. It should not be written like that at this point. But I just want you to point out these are equivalent, but I noticed that they did not clean that up like they should have. So I'm not going to use this value. I'm going to just use the square root of 8 because all of these answer choices have that square root of 8. So just something to pay attention to. I don't like how they do that. It makes it more complicated for you guys. So when I look at my tangent then, my opposite side is the square root of 8. So tangent is the square root of 8 all over 1. So opposite over adjacent, so it's just going to be negative square root of 8. So I plug it into my equation over here. And I get 2 times negative square root of 8 all over 1 minus negative square root of 8 squared. Remember, this is saying your tangent squared. So this is going to equal a negative 2 square root of 8 all over 1 minus. A negative squared makes that a positive. Square root of 8 squared is going to cancel out. So this is just going to be a value of 8. So it's negative 2 square root of 8 all over 1 minus 8, which is going to be a negative 7. A negative and a negative is going to make this a positive. So it's 2 square root of 8 all over 7. Done. And there you go. So again, be careful. Yes, you could simplify that, but all the answer choices were already left as square root of 8. So leave it just like that. Do I have any other questions for the day? Any questions on anything? All right, well, good luck with computer access. Hopefully it stays working. You guys don't have any problems with the way that you log in. The school is having, it is a district-wide issue. So if you do come across a problem, don't think it's your computer or you, and hopefully everything will be taken care of soon if you do have any issues. Awesome. I will see you guys. Reach out to me if you need anything.
Have a good day.
Thank you. Take care.
Bye. Thank you. Have a nice day.
Bye. You're welcome. See you.
Bye.
Bye.
Thank you.
You're welcome.